Hi, my name is James Hauser, and I'm an Associate Professor in the Department of Sustainable Technology and the Built Environment here at Appalachian State University. And you are out now at the NEXUS facility. This is a research and demonstration site that has been around for about 10 years. And what our goal is in this site is to deal with increasing local food production. There's a lot of reasons for that. It helps improve the health of the local community, helps improve the health of the local economy, and hopefully it also reduces transportation of food up to the mountains, which uses fossil fuels. So what we're trying to do is help local farmers extend their growing season. We have a very short growing season in the Appalachian Mountains. So a lot of farmers are doing that by starting to use controlled environment agriculture, which is greenhouse agriculture, inside a greenhouse like this. As you can see, this is a very simple greenhouse. It's called a hoop house. It has just plastic over it, which helps keep heat in and light in during the day, but at night it loses energy very rapidly. So if you want to heat it, it takes a lot of energy to heat it. And most farmers up here use propane to do that. So that's very expensive, and it's not worth it to them. The extension of the growing season and the extra money they would get from those being able to sell their produce at market is swallowed up by the energy cost, so it doesn't work for them. So the idea is, how could you have greenhouses like this that have low energy costs and also don't use fossil fuels? So that's been the main emphasis here. How can we create greenhouses that can be heated with renewable energy and biomass energy? So we're using solar thermal, various other biomass concepts to help heat this greenhouse. So my main work that I do in this synergistic effort is anaerobic digestion and compost. So you've already seen the home biogas unit. That's an anaerobic digester. But we've also done a lot of research in other forms of digesters, and one of the concerns is the cold climate. So anaerobic digestion is taking food waste, taking manure, digesting it, and being able to make gas from that. And that gas can then be used in a hot water heater or other form to create, burn the gas. It's basically natural gas. So the question is, how do we incorporate that into the system? And you can see what we've done is put the home biogas unit in the greenhouse itself, which keeps it warm. And then we can use the gas, if need be, to cook or to heat water if we want. It can be integrated into the entire system. And also the nutrients that come out of the anaerobic digester, in this case using aquaculture, we can use it to help feed the fish and to keep nutrient levels up to the point where it's good for the plants in the system. I also work with compost. So compost itself generates heat. A compost pile can get up to 140 degrees. So we've worked with using compost energy also as a heat source, potentially both for anaerobic digestion and for the greenhouse, where we have heat transfer exchangers in the compost pile, and then we're allowed to send water through the compost pile, pick up that heat, and bring it back to a large thermal battery in the greenhouse. So this site is used for that kind of research and for demonstration, but our ultimate goal is to use this research that we do here to do technology transfer to local farms and to actually help local farms extend their growing season, to allow them to start growing plants earlier in the year by helping them with root zone heating of their growing beds, and to also produce later into the season to extend that. And that gives them maybe 2 extra months of produce that they can bring to local markets to help with their economics, and also to help the local community with their economics and better food, and keeping all of that within the local economy. So that money circulates through the local economy. So our work here, which has been generously supported by BRI in North Carolina, has allowed us to continue to do this research. We have 4 faculty members working on this project, number of graduate students, and we've demonstrated at one farm over a 50% reduction in their propane use in their hoop greenhouse. So we're seeing results, and it's just been a great opportunity to do research.